All right, in this first video for Note 65, I'm going to do problem number 1, which is graphing a quadratic equation. So we've got to find, whoops, sorry about that. Whoop, hold on a second. Let's try that again. We need to find all these little key features here. If you followed along with some of the other videos, this is just a rehash of that. But I will say with this particular equation, I would recommend having a calculator for it, and you'll see why shortly. All right, so step number 1, I am going to find an axis symmetry. So that's going to be x is equal to the opposite of b over 2a. And so for this particular problem, x is going to equal the opposite. Hold on, let me zoom in a little bit. The opposite of b is negative. No, I lied. That's going to be positive 3. And okay, so b was negative 3. The opposite is going to be positive. And then all over 2 times a. A is the coefficient here of x squared. That's 1. So axis symmetry is going to be x is equal to 3 over 2. Because we're going to be dealing with 3 over 2 as part of the vertex, which means I'm going to need to take this x value for 3 over 2 and put it in for those x's. The fractions aren't necessarily going to be the easiest thing to work in. Let me rephrase it. They're not the hardest thing, but they're not terribly easy to work with either, okay? So let's go ahead and deal with the fractions here. We need to find the y value of the vertex. So as I said, I'm going to figure out y is equal to, everywhere I have an x, I'm going to replace it with the 3 halves. So x squared minus 3 times x, and then minus 18. So if you have a calculator, go ahead and throw this in. I'm going to go ahead and do parts of it right now, and then I'll use the calculator at the very end. So 3 over 2 squared is 9 over 4. Minus 3 times 3 over 2 is going to be, whoops, let me not move that. That's going to be minus 9 over 2, and then minus 18. So I'm going to go ahead and grab a calculator. I think I do. I have one right there. So clear out whatever mess was in there. Let's see, 9 over 4. Minus 9 over 2 minus 18. All right, so it's negative 20.25. I don't think this calculator can turn it into a fraction for me. So negative 20.25. Not a huge fan of the decimal answer there. My brain is telling me, I think, let me do the math in my head really quickly. I think it's 81 over 4. 81 over 4. It is. All right, so negative 81 over 4 is the fraction answer. So when we're doing these vertex, these exact answers, yeah, I did write the exact answer there for the vertex. So that would be what I'd be looking for. As far as then the actual graphing portion of it, I would convert both of these fractions into decimals. So let's see, 3 over 2 is 1.5. And then the negative 81 over 4 would be negative 20.25. All right, so let me make the calculator disappear. There it goes. All right, so I've got the axis symmetry, the vertex. Let's talk zeros. So to find the zeros, we're going to set the function equal to 0. So x squared minus 3x minus 18 equals 0. This, I believe, is factorable, because if it's not factorable, then we're going to have to do the quadratic formula. Let's see, 6 and 3. Quick double check. Negative 6 times 3 is negative 18. Negative 6 plus 3 is the negative 3. Yeah, those are my correct factors. So set the factors equal to 0. Right? And that's going to get me x is equal to 6 and x is equal to negative 3. So my zeros are going to be 6 and 0, 6 comma 0 and then negative 3, 0. It's your x-intercepts. All right, zeros have a couple of different names that we use. Y-intercept, that one is nice because we're going to make x equal to 0. So 0 squared minus 3 times 0 minus 18. That just turns into negative 18. So let me put it in the right order there. So 0 comma negative 18. I will deal with domain and range after I've done my graph. All right, that's how I tend to do these problems. So axis symmetry of 3 over 2. That means I want to be halfway between 1 and 2, right? It was 1.5. So let me go ahead and mark in that axis of symmetry. Okay, there we go. Vertex is negative positive 1.5. So that's on this axis of symmetry. But I need to drop all the way down to negative 20.25. So this bar right here, this grid line, is the negative 20. I want to be a little bit below that. So we'll go right about there. I know it looks like it's basically a half. It's kind of hard to do some of those decimal values. Get it close. Let's see, -3, 1 to -3, +6. All right, and then a y-intercept of -18, 15, 16, 17, 18. Get in the right place there. All right, so I've got all the points in the right place. Let me go ahead and draw in my lovely little curve. This is a quadratic, which means it is curved. All right. I am not going to be the person who gets too worried about your curve having a little bit of shake or wobble, but please do make sure it actually is a curve, and you want to make sure that your curve hits through all the points that you have graphed. Domain here, possible x values are going to be everything. All right, there are no limits to what you can put in for x. Range does have a limit for the outputs you're going to get. You'll notice this graph has a lower boundary. There's no point lower than that. So that lower boundary is where we're going to start. So -81/4, and then we are going to go to infinity. All right, that is the work for number 1 here. There's all the little bits, parts, and pieces. I'm going to go ahead and close the video here for this. It is a little bit of a reminder of how to do these graphing quadratic equations. In the second video, I'll go through question 2, 3, and 4, which are graphing quadratic inequalities. As always, let me know if you have any questions or concerns, and I'll see you in the next one.